Good morning, students. Can you hear me? Can you hear me, students? Okay, thank you very much. Everyone is here except for Ada. Okay, hope you had a good break last week. And welcome back to your lessons now. I hope you joined all your classes yesterday, yeah? Did you? Okay, so let's start with our lesson for today. So we are in week 6, right? So we have week 6, week 7, and week 8 before you go for your CT1. All right, now can you remember where we stopped the last time? Extraction of aluminium. Okay, very good. All right, so before we go into our lesson for today, let's do a quick revision of what we learned last week. Okay, all right, so hope you can all see the screen. Revision questions. Okay, question number 1. Yeah, we start with Faria. Name the O for aluminium. Name the O for aluminium. Faria, are you there? Can you see the screen, students? You should be able to see.
Yeah, I responded in the chat.
Okay, hold on. Okay, now that's Isabel. What is the answer? Name the O for aluminium.
Bauxite.
Bauxite. Okay, the O for aluminium is bauxite. Hematite is the name of the O for iron. Clear? Okay, so we move on to question number 2. Okay, so this question is for Natalie. How is bauxite purified? How is bauxite purified? Okay, there's an answer. Let me see. Oh, that answer is from Ashlyn. Okay, Natalie, what's the answer? How is bauxite purified? Bauxite has some impurities in it, so it is treated with some. It's treated with the reagent to purify it. Okay. Okay, that answer is from Natalie. Treated with sodium hydroxide solution. Okay, good. So bauxite is purified with sodium hydroxide solution. Then you get pure aluminum oxide, and the aluminum oxide is used to extract the aluminium. Okay, all right. Now, good. Next question. Question number 3. Name the chemical process by which aluminium is extracted. This question is for Kera. Electrolysis. Okay, good. Yeah, Kira, that's the correct answer. The chemical process by which aluminum is extracted is electrolysis. Now, Hall-Heroult process is the name given to this this extraction of aluminium. Okay. All right, now question number 4. Question number 4. After Kera, that's Tiffany. Why is cryolite added during extraction of aluminium? Yes, Ashley, your answer is correct, but I'm waiting for answer from Tiffany. Natalie, yes, your answer is also correct. So Tiffany's answer, to lower the working temperature of the electrolytic cell. Very good. Yeah. So we learned aluminum oxide during electrolysis has to be in the molten state. Then only it can conduct electricity and the reaction can take place. So to melt this aluminum oxide, electricity is used. So when without the cryolite, the aluminum oxide will melt at a very high temperature. That means a lot of electricity has to be used. Okay, so when cryolite is added, the melting point of aluminum oxide will decrease. So in other words, the working temperature of the electrolytic cell itself will decrease. Okay, all right, good. Okay, we move on to question number 5. Okay, question number 5 after Tiffany, that's Rene. What are the anode and cathode made of? Obviously, this is for the electrolysis of aluminium. Okay, what are the anode and cathode made of in this particular process? Rene, are you there? Okay, come Kylie, what's the answer? Yes, Ashlyn, your answer is correct. Come Kylie, what's the answer? We pass the question to you. What are the anode and cathode made of? Kylie, are you there? Made of graphite. Okay, Kamka, your answer is correct. Both the anode and cathode here are made from graphite. Okay. Okay, next question to Ashlyn. Where are the aluminum ions discharged? So during this electrolytic process, where are the aluminum ions discharged? Okay, this question is for Ashlyn, yeah? No response. Edda, what's the answer? Okay, Edda, what's the answer? Where are the aluminum ions discharged? Discharge means the ion will lose its charge and it becomes an element. So Ashlyn, your answer is correct at the cathode, okay? So the aluminum ions are positively charged. They will move towards the cathode. Cathode is the negative electrode. So aluminum ions will be discharged at the cathode, and then there's an outlet for the molten aluminum to come out. Okay, next question is for Ada. Why do the anodes burn away? Okay, the earlier question was for Ashlyn, and then she answered. All right, Ada, now you answer. Why do the anodes burn away? So during the electrolysis of electrolytic process, we learned that the anode burns off. No, that's not the answer. Okay, anyone? Why do the anodes burn away? Because the graphite is reacting with oxygen to form carbon dioxide. Okay, was this answered? Isabel. Yeah, good. All right, actually in oxygen reacts with graphite. Okay, good. The oxygen, due to the high temperature, the oxygen gas that is formed at the anode will react to form carbon dioxide gas, and then the anodes are carbon dioxide is a gas, isn't it? So that burns away the anode, and therefore the anodes have to be replaced from time to time. Okay, so there are a few more questions we will continue in the later on. So now we have to move on to our lesson for today. We stopped at question number 7, right? Okay. All right, so we stopped at we did extraction of aluminum the last time because we had that combined class. So we still have to, I still have to teach this little bit of extraction of copper. Now, before that, this is regarding week 4 homework, the MCQ questions. Okay, so you have MCQ questions to do every week. So week 4 MCQ questions, everyone has answered except for one person. Okay, so you know who you are. Make sure you answer by today. Okay, so the next class, I don't want to see your work still being not done. All right, so I'll share this link for this week 4 homework 2 times already. Okay, so it's there in their WhatsApp group or even in the EMS system. You look for the link and then do your work. All right, the answers I will discuss during the Friday class. Okay, so now let's look at extraction of copper. Now, when you look at extraction of copper, there's basically not much of a big description like extraction of iron or extraction of zinc and so on. You just need to know that the name for the ore of copper, the name for the ore of copper is called chalcopyrite. It is here copper is in combination with iron and sulfur. And this chalcopyrite is also known as copper pyrites. Okay. Now, the copper that is made from this ore is impure. And we know that most of the copper that is extracted is used to make electrical wires. The electrical wires that comes with the electrical appliances, the wiring in our house, it's copper wire. Okay. So this copper wire has to be very pure, about 99.9% pure. And how is it made pure? By electrolytic process. Okay, I hope you remember the process, electrolytic process, where you have the cathode and the anode. You have pure copper and impure copper. Now, which one will be the pure copper? So this is the anode, all right, and this is the cathode. Which one will be the pure copper, the anode or the cathode? Yeah, pure copper. Which one it will be the pure copper, cathode or anode? Yes, the cathode is the pure copper. Okay, cathode is the pure copper. And this will be the impure copper. Okay, so at the anode, okay, so at the anode, the copper will, at the anode, the copper will dissolve. Okay, so at the anode, the copper will dissolve and then it will go and get deposited. The copper ions will get deposited on the cathode side. Okay, so as time passes on, there'll be more and more pure copper and the impure copper will become smaller. In this way, the impure copper will be, converted to pure copper. Okay. Okay, so this by the process of electrolysis, the impure copper is converted to pure copper. All right. Okay, next we come to the uses of copper. Now, uses of copper, you have learned before. Just I've put everything together to summarize in one place. So copper is used to make electrical wire. Basically, it's a good conductor of electricity and easily drawn out into wires. Easily drawn out into wires means ductile, okay? And plumbing, like to make water pipes and so on, because it doesn't react with water and it is easily bent into shape. Easily bent into shape means it's malleable. All right. Okay. Now, cooking utensils and boilers, it's a good conductor of heat and doesn't react with water. Okay, because of that reason, it is used to make cooking utensils and boilers. To make brass, brass is a copper zinc alloy. Now, we've learned about alloys in detail earlier, so I'm not going to go into that so much. So brass is an alloy of copper and zinc. Now, bronze is also another alloy, but here instead of zinc, you have copper and tin. Okay, so these are some uses of copper. So you don't have to sit down and waste a lot of time memorizing. You just, you just look at understand the use and then try to relate it with a suitable property. Okay, so that's all. If you know that, then you can answer a question. Usually they do ask for 1 or 2 marks, the uses and the property upon which it is based. Okay, so that's about copper. All right, now after copper, it is the extraction of aluminium. So I've done this. So with this, we finish part 1. So I told you I have divided topic number chapter 9 into 2 parts, part 1 and part 2. So now we move on to part 2. Okay, so part 2, if you look at part 1, it's more related to metals, extraction of aluminium, extraction of zinc, extraction of iron. Part 2 is more towards the non-metals. Okay, so in part 2, today we will only look at one part, that is ammonia and fertilizers. Okay, 9.3, ammonia and fertilizers. Now, for this part 2, I have already printed the notes. Okay, you don't have to print it. So when you get back to school, I will give you the hard copy, and for the soft copy, I'll share the link with you all. Okay, I will share the link with you. So this is the link for the part 2. Okay, you can use this link. You have the part 2 with you. Okay, so that's a link for part 2, students. Hope you all have that link and can download the notes. All right, now we will move on to ammonia and fertilizers. Okay, now what's the formula for ammonia? Ammonium is NH4. Okay, so you NH4 plus is ammonium ion. Ammonia. My question is, what's the formula for ammonia? NH3. Okay, good. Yeah. So NH3 is ammonia. Okay, good, Faria. Ammonia is NH3. So we are going to learn about ammonia and fertilizers. Okay, now the Haber process is the process for the manufacture of ammonia. Okay, manufacture means making in a large scale. So the manufacture of ammonia. Okay, now just like every other process, basic oxygen process, Hall-Heroult process. So you have the Haber process for the manufacture of ammonia, but actually it's a very simple simple description that you have to know. So to make ammonia, two gases are needed. One is hydrogen and the other one is nitrogen. And where does this nitrogen come from? It comes from the air. Okay, so whoever is, the people who run this industry, they get one of their raw material free of charge. So the nitrogen comes from the air. Air has got a lot of nitrogen. 78% of air is nitrogen. Where does the hydrogen come from? Hydrogen comes from natural gas that is reacted with steam. So steam is H2O, water. Okay, water in the gaseous form. Now, what is natural gas? Not the gas that comes from our body. That's not natural gas. Okay, don't give me that answer. What is natural? What do you think is natural gas? Gas that comes from the earth. What type of gas comes from the earth? Okay, anyway, that was a good try. Now, natural gas is an example of a fossil fuels. Okay, so fossil fuels are examples of fossil fuel is natural gas, then it is coal, and also crude oil or petroleum. And natural gas is mainly methane or methane, however you pronounce it. Okay, so natural gas is mainly methane gas, and when it is reacted with steam, you get hydrogen. Okay, so the nitrogen comes from the air, the hydrogen comes by reacting methane with steam. Now, the Haber process is a reversible process or a reversible reaction. Okay, so you see here, look at the equation, nitrogen plus hydrogen gives ammonia, and this is the symbol for the reversible reaction. Okay, and this reaction is exothermic, so heat is given out. Okay, plus heat means it's an exothermic reaction. Okay, now who can tell me what is a reversible reaction? What is a reversible reaction? A reaction where the products can be reversed into the reactants. Okay, whose answer was that? Okay, Faria, yeah, partly correct. Okay, so it's a reaction where the reactants can form the product and the products can form the reactants back again. So that is why it's called a reversible reaction. It goes forward and backwards. The reactants will form the product and the products can also form the reactants back. Okay, and how do you know the reaction is reversible? By this double arrow. Okay, so normal reactions you only have one full arrow, so you have two half arrows here. So that's the sign for reversible reaction. Okay, all right, so now let's move to the Haber process. Now the Haber process is also known as the Haber-Bosch process. Okay, so it's called the Haber-Bosch process because it was invented by two people, Haber and Bosch. Now, if you look at the conditions are quite simple. Pressure of 200 atmosphere is needed, temperature 450 degrees Celsius, and catalyst of iron. Okay, what is the function of the catalyst? It speeds up the rate of the reaction. Yes, a catalyst is speeds up the rate of reaction without being changed. Okay, and under rate of reaction in chapter 7, you have learned that high pressure, high temperature increase. When pressure increases, rate of reaction increases. When temperature increases, rate of reaction increases. Okay, so you just need to remember these three conditions. But what happens is the conditions are so simple, and when students write it for exam, let us say the question says state the conditions for Haber process. You just write 200 atmosphere, 450, and iron. Some students, they don't bother to write what is 200 atmosphere. So you don't have to write as a full sentence the pressure is 200 atmosphere. At least write pressure. At least you write like how it is in the notes. Pressure 200 atmosphere. Temperature 450 degrees Celsius. Unit is important. Catalyst iron. Okay, instead of just writing 200 atmosphere, 450 degrees, is better to denote what you are talking about. Okay, atmosphere, you can also write ATM. Short form is also applicable. So these are three conditions: 200 and at a pressure of 200 atmosphere, temperature of 450 degrees Celsius, and catalyst iron. That's all you have to know, the conditions. Okay, no big, extra reactions. Okay, all right, now let us look a little bit more on the Haber process. So just like if you look at just like the other processes, this also needs a place for the reaction to take place. So if it is extraction of iron, it took place in the blast furnace. Electrolysis took, it was in the electrolytic cell. For this, you have a reactor. Okay, so don't worry, you will not be asked to draw this diagram, or I don't think they will even ask you to label or anything like that. So I put this diagram just for you to have an understanding of how the reaction takes place. Okay, so here just now we learned that for the making of manufacture of ammonia, nitrogen and hydrogen react to form ammonia, isn't it? So this is the equation. Of course, when you write equation, make sure you balance it. Yeah. So now we will just go on to the process. So hydrogen and nitrogen are fed into the reactor. Okay, so they are gases, so they come here. So here you have all the conditions: the 200 atmosphere pressure, the 450 degrees Celsius temperature, and you have the catalyst, which is iron. So all the conditions are set inside the reactor. So what happens? The reaction takes place. Now, nitrogen, hydrogen, and ammonia, all these three are gases. Okay, and reversible reaction means the reactants are forming the product. The products are also forming the reactant. So there will be a mixture of all the three gases at one time. Okay, ammonia will be formed at the same time. Some ammonia will decompose. So there will be a mixture of three gases. So gases, we know wherever there is empty space, they will just move in. So here, this is the only outlet, right? So all the three gases will go here. So now here you have a mixture of nitrogen, hydrogen, and ammonia. Okay, do you follow that? So now you have a mixture of nitrogen, hydrogen, and ammonia. So all these are gases. How to separate the gases? So that is why where the condenser will help. So this is the condenser, as you can see here. So condense means, okay, tell me, what is condense? Condensation, what does it mean? Gas to liquid. Okay, good, Ashley. Changing from gas to liquid. Okay, so inside the condenser, so condense mean changing from gas to liquid. So inside the condenser, what happens? All the three, the temperature will be very low. Okay, so when the temperature changes, the gas will condense to liquid. So inside the condenser here is, you can see, coolant. All right, so inside the condenser, the temperature is very low. So the gases will be cooled. But what happens is, when compared to nitrogen and hydrogen, ammonia will become a liquid first. Okay, because of the boiling point of ammonia will become a liquid first. So you don't have to go into all the detail. You just know inside the condenser, the temperature is very low. So the gas that first becomes a liquid is ammonia. So when ammonia is a liquid, what happens? It will come down, isn't it? Ammonia is a liquid, so obviously it was going to come down because of the density. So here the ammonia will collect, and then there's a tap here which can help to remove the ammonia. Now, nitrogen and hydrogen are gases. Okay, so these gases will go through this outlet and they will come back here. They will be reused again. Okay, so this is how the Haber process works. Is that okay? So basically, for the Haber process, what you need to know is the equation for the Haber process, where the nitrogen comes from, where the hydrogen comes from, then the conditions for Haber process, and how the ammonia is separated from the nitrogen and hydrogen. Okay, so that's about it. All right, now, Isabel, I want you to read these points. The Haber process key facts.
Hydrogen and nitrogen are mixed in a 3-to-1 ratio. Because the reaction is reversible, not all the nitrogen and hydrogen will convert to ammonia. The ammonia forms as a gas but cools and liquefies in the condenser. The hydrogen and nitrogen which do not react are passed through the system again, so they are not wasted. The ammonia produced is stored as a liquid under pressure. Most of the ammonia produced is used to manufacture fertilizers.
Fertilizers. Okay, so that's about the Haber process. All right, now let's look at the properties and uses of ammonia. Ammonia is a colorless gas and it is alkaline in nature. That is why it will change a damp red litmus paper to blue. Okay, so ammonia gas is an alkaline gas. It is an irritant. Okay, what do you understand by this term irritant? Okay, that's an answer. Can affect the skin when in contact. Yes, so affects the skin, and also it can affect the respiratory system. Okay, so if you come across a place where there's a leakage of ammonia, it's better to run for your life, because it's a harmful gas as well in high concentration, but in small amounts it's not that very harmful. Okay, so it is an irritant. You have to be careful of this gas, and it has got a characteristic pungent odor. Pungent means it has got a very strong smell. Okay, so even if you have to, even if you smell a little bit of it, it will be very sharp. It has got a characteristic pungent odor. Odor means smell. Yeah, odor means smell. Okay, it is highly soluble in water. It is a gas that can dissolve in water very quickly. Now, uses of ammonia. Now, this ammonia gas, 90% of ammonia is used to make fertilizer, right? Now, fertilizers are, I'm sure you know, they are chemicals that are added for plants to grow well. And not only that, they also used to make nylon. Okay, nylon is a synthetic fiber. They used to make clothes and all. Nitric acid, pesticides. Pesticides are chemicals that kill pests, and also dyes. Dyes are the coloring matter, the chemicals that give color to your clothes and other stuff. Okay, so these are some uses of ammonia, but the major use of ammonia is to make fertilizer. Okay, so that's about the Haber process. Any question on the Haber process before we move on to the fertilizer part? Any questions, student? Okay. Oh, no question. All right, good. Okay, so now we move on to fertilizer. Okay. Now for fertilizer, I will use my PowerPoint slide, okay? But not to worry, the notes are the same as, whatever notes you have and the notes that are here, they are the same. It's just that the last time when I gave this to the student, some of them, they printed it and then they complained that they had to use a lot of ink. Okay, so now I just give the notes in black and white. All right, so not to worry that these slides and this information and whatever information is given there is the same. It's just that this is in color, that's all. Okay, now who can tell me why do we need fertilizers? I told you just now what fertilizers are, but why do you think we need fertilizers? Okay, so if you look at the jungles and forests, there's so many trees, no fertilizer there, but why do we need fertilizer? Okay, good. It promotes the plant to grow well and grow healthily, yeah, and to increase the yield, because the population of the world is increasing, isn't it? So you need so much food to feed this growing population. Okay, so let's look at what is a fertilizer. Okay, a fertilizer is any material of natural or synthetic origin, which is added to the soil to supply one or more plant nutrients. So fertilizers can be natural, can naturally made, or they can also be man-made or synthetic. Okay, and just like us, okay, we also need nutrients, isn't it? What nutrients do we need for our body? What nutrients do we need? Okay, we need vitamins and minerals and all that, right? Yeah, proteins, fats, carbohydrates. Okay, good. Just like that, the plants also need some nutrients. Okay, so that is supplied by the fertilizer. Okay, now let's come back to this. So once again, fertilizer is any material which is natural or synthetic, and that is added to the soil to supply one or more of the nutrients. Okay, so let us say what nutrients plants need. Now, if you look at fertilizers, there are two main types of fertilizer. Okay, of course, there may be many, but your syllabus, you only have these two. The nitrogenous fertilizers, okay, and then the NPK fertilizer. The two types of fertilizers that you will be studying about, the nitrogenous fertilizers and the NPK fertilizer. Okay, so not to worry, quite easy to remember. Now, nitrogenous fertilizers, they have high nitrogen content. Okay, so though air contains 78% nitrogen, we cannot directly take the nitrogen from the air because nitrogen is an inert gas. So our nitrogen content comes from the plant. So we have to supply that. Even plants can't take the nitrogen directly from the air. Okay, so they also have to be supplied with these nitrogenous fertilizers. Okay, because nitrogen is important for our body, for proteins, for amino acids and things like that. Okay, all right. So nitrogenous fertilizers, from the name itself, you know, they have high nitrogen content. These nitrogenous fertilizers are also called straight N fertilizers. Okay, so straight N fertilizer, it's there in the notes as well. They are called straight N fertilizer. All right. Okay, you must have seen these sacks of fertilizers, you know, at least once, maybe at home or, you know, in a farm or watching TV. Okay, so this is how fertilizers are packed. Okay, now examples of these nitrogenous fertilizers are ammonium nitrate, urea. So nitrogenous fertilizers, they contain a high percentage of nitrogen. Examples will be ammonium nitrate and urea. Okay, so now we move on to NPK fertilizer. So NPK fertilizers, from the name itself, we know that they are a mixture of elements. So nitrogenous, they only supply one nutrient, which is nitrogen. NPK is like the multivitamin. Okay, so they have like nitrogen, and so they have nitrogen, phosphorus, P for phosphorus, and K for potassium. So the NPK fertilizers will supply nitrogen, they supply phosphorus and also potassium. So that is why they are called NPK fertilizers. Okay, and why is it essential to have this NPK fertilizer? Because these elements, they are very easily removed from the soil. For example, let us say the farmer, he plants his crop, okay, and whatever phosphorus and potassium is in the soil will be used up by the plant, and then the next time when he grows the next set of crop, okay, then the soil does not have enough of this nutrient. So that is why he has to put fertilizer in the soil. Okay, all right. So NPK fertilizer, nitrogenous fertilizer, remember. Okay, now let's look at the use of each element. Okay, so just like our body, we need iron, sometimes we need calcium and all these things, isn't it? So nitrogen is needed by plants for healthy leaves. Phosphorus is needed for healthy roots. Phosphorus for roots. Okay, remember. Potassium for flowers and fruit. So these are the uses of these elements. Okay, so very easy to remember. Nitrogenous fertilizer have mostly nitrogen. NPK fertilizer, nitrogen, phosphorus, and potassium. Okay, so nitrogen for leaves, phosphorus for roots, and potassium for flowers and fruits. Okay, so let's move on. All right, so if you look at NPK fertilizer, it's very difficult to have one fertilizer with all the three. Okay, I think there is not much of a 3-in-1. So you have to have 3 different chemicals here. Okay, 3 different chemicals. So NPK fertilizers usually are a mixture of ammonium nitrate. Okay, we already saw ammonium nitrate earlier. Ammonium nitrate has nitrogen, ammonium phosphate, and potassium chloride. Okay, ammonium phosphate will supply the phosphorus. Potassium chloride obviously will supply the potassium, ammonium nitrate for the nitrogen. Okay, so NPK fertilizer has a mixture of all these 3. Okay, and different plants, they need different percentage of potassium or phosphorus. Okay, like sometimes, you know, when you're deficient with iron, then you have to take some iron tablet. Some of you might not have enough calcium, so maybe you have to take calcium supplements. Some of you, your immune system is so weak, you need some vitamin C. So different plants need different amount of the elements. Okay, so there is something called NPK value. So nothing new here, NPK value. All right, so what is NPK value? It's just a number. All right, NPK value are just numbers that tell the farmer how much of each element is present in the fertilizer. Okay, for example, you will see, okay, this is on the bag of the fertilizers, they're sold in bags. Okay, so on the bag of the fertilizer, you'll find a label like this. So this label will give the NPK value. So this is for nitrogen, for phosphorus, and potassium. So this is potassium nitrate. So obviously there's high 13, maybe about 13%, not maybe lah, 13% is nitrogen. No phosphorus, obviously from the name itself, you know, there's no phosphorus here, and there's 46% potassium. So what is NPK value? It's a number that tells how much of each element is present in the fertilizer. Okay, so that's about it. So don't worry what, you know, there's no maths involved here. It's just a number. Okay. All right. So now let's look at how fertilizers are made. Okay, so we learned earlier that, you know, ammonia is used to make fertilizers. Okay, before we go into making fertilizer, any questions so far regarding the nitrogenous and NPK fertilizer? Any question? Okay, no question. All right, so ammonia is an alkali. Okay, so in order to change it to a fertilizer, it has to be reacted with an acid. So you have learned under acids and bases the topic there, right? Acid plus alkali will give salt and water. Okay, so acid can be, so in other words, what happens? An acid or alkali can be neutralized. That's the meaning. And one important thing is that all ammonium salts are soluble in water. Okay, so if it is ammonium nitrate or ammonium phosphate or whatever ammonium salt, it will dissolve in water. Then only what happens? Only when the ammonium salt or when the fertilizer dissolves in water, the roots will take the salt, isn't it, to the plants, and the plants can make use of it. So all ammonium salts are have to be soluble in water. Okay, so all these pictures will give you an idea of how fertilizers look like, so those of you who have never, never have any interest or any idea about all this, just to give you an idea. So this is how fertilizers will look like. Okay, just like the salt that we have at home, but actually it is something different. Okay, now one example of a fertilizer is reacting ammonia with sulfuric acid, and here you get only one product. Okay, remember that in this case you get only one product. Aqueous ammonia is reacted with sulfuric acid, you get ammonium sulfate. Okay, this aqueous ammonium sulfate. So one product only. So here, why is it? And when you look at the formula, ammonium is NH4 plus, sulfate is SO4 2 minus. Okay, so your formula will be NH4 twice SO4. Okay, NH4 twice SO4. Okay, now, so that's for ammonium sulfate. Okay, and ammonium nitrate, this is also another example of a fertilizer. Ammonia plus nitric acid, you get ammonium nitrate. Okay, so ammonium again, NH4 plus NO3 minus, so it is NH4 NO3. Okay, I think the problem, this reactant part won't be much of a problem, but you must know the formula for nitric acid and sulfuric acid. Okay, if you do not know, then you will have problem writing this equation. So ammonium nitrate, once you know the symbol for the ions, you can write the formula. Okay, all right. Now, do you think everything about fertilizer is good? Have you read somewhere or have you come across some negative effects of fertilizer? Anyone? Okay, there's an answer. Okay, you are sure that there are negative effects. Okay, let's see what are the negative effects. Yeah, all right. There's one more. It makes the plant less adaptive to natural environment and can impact animals and endanger insects. Yes, there are some negative. Let us see what the negative effects are. Okay, now some fertilizers, they tend to make the soil acidic. Okay, so acidic. So what they do is to overcome this, the fertilizers are mixed with chalk. Chalk is calcium carbonate. Okay, so this calcium carbonate will react with the acid and it will neutralize the acidity. And the fertilizers that are sold like this are called nitro chalk. Okay, so yes, fertilizers can make the soil acidic, but there's also a way to overcome this. Okay, now during when you learned about acid, bases and salts, you must have learned this equation: metal carbonate plus acid forms salt plus carbon dioxide plus water. Okay, so when the fertilizer makes the soil acidic, but due to the presence of the calcium carbonate, the acidity will be neutralized. Okay, so that is one way of how the negative effect of these fertilizers are overcome. Okay, all right. Now these are some pictures of how fertilizers look like. Okay, some of them are powder form, some of them are in pellet form. So this is how they look like. Okay, now another disadvantage of fertilizers is it because we learned that ammonium salts are soluble in water. So when it rains, what happens? The fertilizers will be washed away by the rainwater, and then they will end up in rivers and lakes. So when they go to the river and lake, because of this extra nutrients, a lot of this algae will grow. Okay, so if let us say this is a river, so on the surface here you'll find a lot of algae that grows, and this is called algal bloom. Okay, algal bloom. Now because of this algal bloom, what happens? It blocks the sunlight. There won't be sunlight for the for other aquatic plants or the fish. Okay, the fish inside the water, they will not get enough oxygen. Okay, not only it blocks the sunlight, the algae will use up all the oxygen in the water, so there won't be enough oxygen for the aquatic animal, the fish and other small plants, so they will all die. So it ends up like a dead area. So this is another negative effect. Okay, so you see here, this causes pollution resulting in fish dying and algal bloom, a green coating that covers the water. Okay, so because of this algal bloom, there's not enough sunlight for other plants to grow, and also there's not enough oxygen for the fish. So this whole area will be like a dead area. So that is a negative effect of using too much fertilizer. All right. Okay, so there's a little bit more, but anyway, I do not want to. I will do it in the next class. Okay, so to summarize what we learned today, we learned about uses of copper, then we learned about the Haber process and about fertilizer. Okay, now the last week, week 4, I told you to do one question, right? Page number 249. Question number 4. Question number 4. Have you done that homework, student? Page 249, question number 4. I discussed one question with you, and page 249, question 4, I ask you to do. Well, I didn't give you any homework, I think. Okay, now can you write it down? Page number 249. Textbook page 249. You need to complete questions 3, question 3 and 4. Okay, complete question 3 and 4. So when you get back to school, I will collect your book and then I will mark your work. Question number 3 and 4. All right. Okay, any question regarding today's lesson? Do you have any questions, student? Okay, if no question, then I will end the session because the next class is already waiting. Okay, see you in the next class.